In this video, we'll look at the normal distribution, and we'll use normal distribution to determine probability using z-scores. So let's read the question first. The success rate of shots on goal in an amateur hockey league's games is normally distributed with a mean of 56.3% and a standard deviation of 8.1%. Question A says, in what percent of the games will fewer than 40% of shots on goal score? So what we're looking for is what's the probability that X is less than 40, or 40%. The way we use z-scores is we convert this variable we're looking at to the base normal distribution function by taking that value, subtracting the mean, and dividing by sigma. So we take 40 and we subtract the mean. What's the mean? 56.3. And we divide by the standard deviation. What's the standard deviation? 8.1. So what that does, the way this works is we're saying we're going to look up the probability. The probability of this on its own distribution is the same as looking up this number, whatever it turns out to be, on the base distribution that we call z-scores. So this is the same, this probability here is the same probability of the z-score being less than, what's 40, take away 56.3, and then divide by 8.1, and you get negative 2.01. We use 2 decimal places, because that's what our z-score table has. In other words, if you look up this on its own distribution, we have to make its distribution. It would take forever. Instead, we can just transform it to our base distribution, our z-score table, and look up this number, and that number will be the same number. We'll have the answer. So we take a z-score table, and we look up, we want negative 2.01. So this side's the negatives, negative 2.0. So this column is negative 2.00. So this column is negative 2.01. So that's right here. And we get 0.0222. And that's the answer. Therefore, the probability is, and we can move the decimal over 2 places for percent, 2.22%. That's the probability of having less than 40% of the shots on goal score. Question B for this question says, in what percent of the games will the success rate be between 50% and 60%? So what that is asking is, what's the probability that X is between 50 and 60? Well, and the way we solve that is really, what we really want to know is, what's the probability that X is less than 60? So we're going to find everything from 60 below, and then subtract everything from 50 below. If you take everybody below 60% and subtract off everyone below 50%, what you're left over is going to be between 50 and 60. Everyone below 50 is taken off. What's left? All the 51, 52, everyone in the range 50 to 60. So that's an important step. When you want to find from 50 to 60, you take the second number, find its probability, and subtract the first number. But we can't do that without looking up the z-scores. So we got to convert the 60 to a z-score. We're going to subtract 60, take away the mean, it's 56.3, and divide by 8.1. And then we'll look up that probability, and then we'll take away this one, take away the mean over sigma. So we want to do 50, take away 56.3, and then divide by 8.1. Almost ran out of room there. Okay, well now it's going to be less squishy. This will be the z-score. And so what's 60, take away 56.3, divide by 8.1, and you got to round to 2 decimals. So that rounds to 0.46. minus the probability of the next z-score being less than, and it's 50, take away 56.3. Notice I hit equals here. That's important. Hit equals before you divide, so your calculator does the division after the subtraction. And you get, round it to 2 decimals, that'll be negative 0.78. Negative 0.78. And now we just have to look up those z-scores. Let's look them up. First one, z being less than 0.46. So these are the negatives, so I want the positives. 0.4, and then go out to the 6th column. You get 0.6772. 0.6772. You see that? Minus, and now we want to look up a z-score of negative 0.78. So negative 0.7 and all the way out to the 8th column, and you get 0.2177. And we definitely rounded there. So I should say the z-scores are rounded, but I definitely need a rounding dot here. I probably should have put one here too, because we rounded this z-score. This fraction came out to a big decimal. Same here. Need rounding dots on those lines. Now we'll calculate that. 0.6772 minus 0.2177, and you get 0.4595. 4595. Therefore, the probability is approximately 45.95%. That's part B done. What is part C asking? It's a different question because it says, what's the probability that a game will have a success rate of more than 66%? So what's the probability that X is greater than 66%? Well, the lookup tables we're going to do are always less than. So the first thing we have to do is, if we want to know greater than, we do 100% or 1, which is 100% as a decimal, take away the probability of X being less than 66. So when you're looking for greater than, you just do 1 minus the probability of it being less than. And now it's the same work. That's 1 minus the probability of, and we'll make it into a z-score by subtracting the mean and dividing by sigma. So that's 66, take away same mean as before, 56.3, all divided by same standard deviation, 8.1. So it's 1 minus the probability of a z-score being less than, that's 66, take away 56.3, don't forget to hit equals, divide by 8.1, and don't forget to round, rounding dot. And this rounds to, the 7 means round up, so you get 1.20. Okay, we need to look up that z-score now. It's my z-scores table. So, I want to look up a z-score of 1.20. So here's 1.2 in the O column, 0.8849. So it'll be 1 minus 0.8849. You can do that in your head, or use a calculator. What's 1 minus 0.8849? And you get 0.1151. Therefore, the probability is, and we can move the decimal over 2 spots, 11.51%. So these examples are how to do normal distribution. In particular, we're determining probability using z-scores.